making sure which slide I had to be on. Okay. Okay. Did this one already, sorry. Zip through these. Alright, so here's my ionization energy versus the atomic number. So notice that helium is really high. It's really hard to take it away from helium. Helium really wants to hang on to that electron, doesn't want to give it up. Notice that all the noble gases are really high. Noble gases are very, very stable. They do not want to lose electrons, they don't want to gain electrons. So it's really hard to take any away from those. Okay, so in general, first ionization energy decreases from top to bottom, and as size of the atom increases, the nuclear charge has a smaller effect of the electrons in the highest occupied energy level. Just basically remember that the ionization energy increases as you go up the chart, increases as you go to the right. Okay, so that's what we're saying here. Increases as you go up and to the right. So the highest ionization energy is helium, lowest is going to be francium. Now let's talk about the size of these atoms, because this is kind of weird. This is the weird one here. In metals, things like lithium or iron or whatever, atoms tend to lose electrons. Nonmetals tend to gain electrons. Now think about it. If something's going to lose an electron, is it going to get bigger or is it going to get smaller? It's going to get smaller. On the other hand, the nonmetals that gain electrons, they're going to get bigger. Okay, so cations are always smaller. Cations, remember, are the positive ones. Those are the ones that lost an electron. They always get smaller. Anions always get larger. They gained electrons, so they're larger than the original. So here's some examples. Lithium, okay, loses an electron, and look at how much. These are relative sizes here. Look at how much smaller it gets. Well, it's losing actually entire levels. So it didn't just lose an electron, but it lost that whole level now, so it's much smaller. So sodium loses an electron, gets much smaller. Potassium. On the other hand, all the nonmetals, they gain electrons, and look at how much bigger they get. All right, so metals that are representative elements tend to lose all of their outermost electrons. In other words, what we're saying is, like lithium, sodium, those things, they have one electron in the outer level. They lose the whole thing. Magnesium, beryllium, so on, they have two. They lose them all. Therefore, they get one less level when we're all done. Nonmetals, like halogens, they gain electrons. Therefore, they get bigger. As they get more electrons, they have one less negative or positive than they do negative. Therefore, it can't pull it in as much. So from left to right, you get a gradual decrease in size of cations, followed by a gradual decrease in the size of anions. Okay, so let's take a look back at the periodic table again. And so let's switch back over to that. All right. Let's erase some of this stuff we got here. Okay, so what we're saying is, as these guys here, they're losing electrons. They lose all the way to kind of here. These guys are losing, so they're going to get a lot smaller. So these guys gain electrons over here, gain. So they suddenly get bigger. But our general trend for size as we went across the chart was to get smaller. So, and I always draw it so that my arrows always point to the bigger ones. So here's what's happening. We're starting here. These are pretty small, and we're getting bigger. And then what happens is it gets really, really small. We get this big jump, this big break right here. And then it gets smaller, and then it gets a little bit bigger as we go across here. So small. Okay. Smallest here. Getting a little larger over here. And then the trend is still the same as I go down. They always get bigger. Okay, so it's just because here these guys on this side right here, they gain electrons. That makes them get bigger. These sides lose electrons. That makes them in general get smaller. So this is kind of a weird one. It follows the trend in general, but you just got to remember that, like, your biggest one overall would be like right in here. That's your biggest overall. Okay, back to our let's go to trends in electronegativity now. We got one more. All right, electronegativity is the ability of an atom to attract electrons. So it's kind of the opposite of what we were talking about, ionization energy. Ionization energy is how strongly you hang on to an electron. Electronegativity is how you go try to steal another electron, somebody else's electron. Okay. Now, we don't even talk about the noble gases in here because they don't have any electronegativity. They have no desire to gain electrons, so we don't even talk about them. So in general, electronegativity decreases from top to bottom within a group. For representative elements, the values tend to increase from left to right. All right, so let's talk about it on the periodic table. Okay, so on the periodic table, the once again, we aren't going to even worry about these guys. Take them out. My highest ionization energy is fluorine. So what happens is things increase as I go up the chart and I go to the right. Now notice that our trends either are up and to the right or to the left and down. You know, I mean, they're always the francium and fluorine, you know, or francium and helium, depending on what, you know, if we count all those are my extreme ends. Okay, so what we're saying here is fluorine, very electronegative. In other words, if you're around fluorine, it's going to try to steal your electrons. Okay, francium, yeah, it doesn't even care. It's going to give up that electron. So it's not going to try to steal somebody else's. It'd rather get rid of it, to be honest. So that's what's going to happen there. All right, so let's take a look at a summary of these trends that we have. Trends that exist among these properties can be explained by the different atomic structures. So if we talk about where the electrons are and why they're there, this is why this happens. The increase in the nuclear charge within groups and across periods explains these. Now this is important that you understand. As we go down levels, we have the shielding. We don't have shieldings, we go left and right. Okay, so you need to make sure you understand that. Okay, within groups, an increase in shielding has a significant effect. So as I go down, I get this shielding effect. Now they don't draw theirs the same way I do. I mean, I always draw my arrows so that they always go to the bigger ones, points to the bigger ones. Just easier to remember it that way. And I think if you just kind of get that in mind, you'll be okay as you do all this. But this is, you know, they just show you what happens. As you go to the right, the atomic size decreases, ionization energy increases, electronegativity increases, nuclear charge increases, shielding is constant, okay? If you go down, you know, you've got the atomic size increasing, ionic size increasing, ionization decreasing, electronegativity decreasing. All right, let me show you what I like to do. Here's what I think of when I do this. Okay, if I want to remember these, this is what I'm going to do. Let's add a page on here so I have something new to write on. Okay, if I'm talking about ionization. Now, remember, ionization energy is how hard is it to get an electron? How much, you know, to take it away from something. Ionization energy increases as you go up and to the right. Okay? Electronegativity. Electronegativity is how much are they attracted to each other. Okay? How much do they want an electron? Electronegativity increases as you go up and to the right. Okay? So those two go up and to the right. Size ones go down and to the left in general. So if we're talking about the radius, it gets bigger as you go to the left, it gets bigger as you go down. And if we're talking about ionic size, definitely gets bigger as you go down, but it's kind of weird because it gets bigger and then kind of jumps and gets really, really little and then gets bigger. So we go across there. So really, this is the smallest right there, and then kind of would carry over from here to there. Okay, so but notice that your size ones, these are your size ones. Bottom left is your biggest size. Your energy ones, electronegativity ones, top right. That's the main thing. If you remember that, you'll be able to figure out all of these things that go along with it. All right. Now, once again, make sure you've got those objectives written in your notes.